Okay, so today we're going to start by opening up our VS Code and then opening our BlueSky environment. So we're going to look in the Explorer, and under BlueSky Prototype, we're going to go under SRC and then Integrator. And then first we're going to go to the run config toml file. And this file has all of the run configurations used to do any of our model runs that we can edit to make some different choices and run different scenarios. So the first choice that we have to make is what mode we want to run our model in, and we have three different choices. So the first mode choice is standalone. So that means you would run either the electricity, the hydrogen, or the residential module independently of any of the other modules. So you run it by itself. The GS combo would solve a combination of these modules using a Gauss-Seidel method. So what this method would do would we run the hydrogen module, we solve the hydrogen module by itself, and then we take those results and input it into the electricity module, and then solve that, and then take those results and input those into the residential module and get a new set of results in the residential module. And then these three modules iterate back and forth until a convergence has been defined through the whole module that we'll define later. And then this unified combo is something new that we're trying at EIA. So here we're iteratively solving the unified combination of modules. And what that means is instead of solving each module separately, we combine all of these modules together with the residential, the electricity, and the hydrogen modules as one larger optimization problem, and we solve all three together at once, which gives a little bit more flexibility as well. And if you would like any more mathematical details about either of those methods, there's some additional details and readings in the README as well. And then below, you can select the modules to run, selecting either true or false for all three modules. And then we have a selection of choices for the iterations. So in terms of forcing 10 iterations or not, setting a tolerance level between iterations, and then setting a maximum number of iterations that you would like. Here we have a default temporal resolution, and then we have a set of CSV switches for defining the year and regions that you would like to run the module over that I'll go over in a little bit. And then here below this set of comments are the inputs for each individual, either the electricity, residential, and hydrogen modules. So the electricity module comes with a set of switches in terms of trade and capacity expansion that you can turn on and off, as well as a linear and nonlinear learning switch as well. The residential module also comes with a sensitivity test that you can look at the sensitivity of a set of variables, and it will display a plot if you would like to see that. And then the hydrogen inputs just takes in a hydrogen data folder. So in terms of the total model scale, we have two different CSVs that we included the region and then year sets over. So that's under the BlueSky prototype, and then SRC, integrator, and then the input files. The first one for region is SW_region CSV. And so here we have the regions from 1 to 25. And if you would like the models to be run on a certain number of region, you just put a 1 next to that region number. And then for the setting the number of years, we have the SW_year CSV. And you can run any number of years from 2023 to 2050. The years that you would like to select, you just put a 1 next to next to that year. So right now we just have region 7 and years 2025 and 2026. And in order to run the models, you come into the terminal and you type Python main.py, then -- mode, and then select the mode that I went over earlier. I'm going to run this with GSCombo. And then based off of the run config file earlier, I set true to all 3 modules. So we're running with the electricity, hydrogen, and residential module. So the output that you'll see in the terminal screen will tell you the iteration number, the objective value for all 3 modules in terms of the electricity, hydrogen, and residential module. And then we have iteration 0, 1, and 2 because the model converged after these 3 iterations. And then any additional results in terms of plots that are coming from these modules or the sensitivity results will be located in your output file and then in the output folder, and then the additional folder name will be whatever mode you ran along with the date.